In this session, we'll be discussing about different types of operating systems. The first one is non-preemptive based, preemptive based, priority based, time sharing based. The non-preemption is nothing but there should not be having any kind of interrupts. Preemptions are nothing but you can make it a suspend so that the current resources which are allocated to that particular process can be deallocated temporarily. So they can be utilized to some other process. Priority. High priority is always killing low priority or suspending low priority jobs. Time sharing. Each job is running based upon time quantum. It is based on a round robin fashion. So based on this, there are different kinds of operating systems we have: batch, uniprogramming, multiprogramming, multitasking or time sharing, single processor operating system, multiprocessor operating system, real time or time bounded. We may be having a distributed, clustered, handheld operating system. Many are. But a very important thing is multitasking only. Right now, your Windows or Linux or any kind of operating system is completely based on multitasking or time sharing manner. So first let us see what is a batch operating system. So group of jobs are packed together, then only process begins. So CPU is not get to be wasted. When it is on, it has to complete several tasks. Then it will be off. So users submit the jobs. The job may consist of program, data, control information to an operator. The computer processes them in batches without user interaction. It delivers like anything. Advantages: it shifts the time of job processing to when the resources are less busy and avoids during the CPU between manual tasks. Disadvantage: there is a lack of interaction between user and the job, and debugging is difficult due to long turnaround times. Because you submit the job today, after 10 hours or 12 hours, you have to go there and collect your output. So let me show you an example. So there are some jobs. Job 1 and job 2, job 3. They have to, they're already available in memory. According to first come first serve, job 1 is given to CPU. So CPU is running job 1 right now, and the job 1 needs IO. Job 1 needs IO time. Right now it is with the CPU, and job 1 need IO time also. Right now the job 1 is reached to IO state. IO state means the job may require some inputs from the keyboard, or job may require some output to be displayed onto the screen. Now CPU is idle now because you have removed the job. You have removed the job from CPU and the J1 has entered into IO. Now in this case, CPU is idle because you need to complete the job. Then after J1 completes its IO, then it goes to back, and from there again it goes to CPU. As long as J1 is in the IO, the CPU is idle only. You can't send the next job like J2 or J3 whenever J1 is continue the execution, maybe with the CPU or maybe with the IO. So this is the main funda concept of batch processing. So what is an idea? There are some jobs like J1, J2, and J3, and they have arrived at same time. 0, they have all arrived. This is your process ID. And J1 needs CPU time 1 unit, and it need IO time 100 units. And J2 need 1 unit. It doesn't require any IO. It also doesn't require any IO. So what is the visual here? What is the visual here is, right now CPU consists of J1. It executes 1 unit, then immediately OS will send that J1 to IO because it needs IO bus time also. Then in memory you are having J2 and J3 also. You can't send J2 to CPU. You can't send J3 to CPU unless J1 is completed. So that's why turnaround times are more in this case, and waiting time to J2 and J3. So to avoid that problem, they have introduced extension to batch operating system, which is known as multi-programming OS. So this is how it looks like. So whenever job 1 is with CPU, and if at all job need any IO, it comes here, and you can't place job 2 in this case. You can't place job 2 because job 1 is not yet completed. So CPU is get idle unless and until job 1 has to come back to CPU, come back from IO to CPU. So it is an extension to batch OS. The idea is it could able to run multiple programs at a time. It could able to run multiple programs at a time. So when two or more programs are in memory at the same time, sharing the processor is referred to as a multi-programming operating system. Multi-programming assumes single processor is nothing but CPU that is being shared. The operating system keeps several jobs in memory at a time. The set of jobs is a subset jobs that are in whole. What is the idea? The multi-programming OS monitors state of all active programs. This ensures CPU is never idle. It increases CPU utilization by organizing a jobs to that CPU always has one to execute. It increases CPU throughput, but only problem is no time sharing. Let me show now a figure. Your memory consists of, right now, there are some jobs have come to ready queue. Job 1, job 2, job 3. Right now they are. And I want to send one process to CPU. Right now CPU is idle. So I'm placing J1 to CPU. So right now J1 is busy. If it is completed, okay, leave it, then J2 will go there. If at all it needs any IO, input and output operations you need, then operating system understand that you are throwing a system call that you want to access some IO device. Right now J1 is here and J1 is cleared from this. J1 is cleared from this. Now, if it is in a batch operating system, you can't send a job 2. But if it is in multi-programming OS, I can send job 2 because job 1 is in IO. That's it. There's a simple difference between batch processing and multi-programming. If at all J2 also is in IO, then I can switch another job, that is J3. So every time you see that CPU is busy with some job, the simple difference between multi-programming and batch processing. But only one problem is there. I will show you what is the problem with this. So there are some processes P1, P2, and P3. They have arrived at the time 0 and it need burst time, CPU burst time. It wants CPU 200 units. It needs 1, it needs 2. Then how they are being executed? So right now your memory consists, ready queue consists of P1, P2, and P3. So P1 is sent to CPU because it has come first, and P1 is here right now. It needed how many? 200 units. So it is staying with the CPU like anything. It is using a more resources of CPU. Then in this case, what happened? You are not giving any chance to P2 and P3, though they need only single and 2 units only. So during the execution of 200 units of time, you could able to successfully completed how many jobs? Only one job. That's why throughput is less, especially in a multiprogramming. If at all it is a 2000 units, then see, it's a pathetic situation to P2 and P3. They are unable to get access CPU. So in this problem is eliminated in multitasking operating system. What is a multitasking operating system? Time sharing. Though you are needed 200 units of time, I don't give you to you access 200 times of CPU. I will give fixed time, 2 units or 10 units. Once you completed your 10 units, again you have to come back. Next round you will go and access CPU once again. That's why it is completely based on round robin fashion. Sometime the process with ready queue and sometime the process with the CPU. So J1 is executed 10 units of time. So you have to simply come back. Then ready queue will dispatch J2. J2 if needed 10 units of time, execute it. Then come back J2 to ready queue and give a chance to others. So able to give a chance to all the process so that there is a need, there is a what's happening, there is a provision of fairness, sharing the resources uniformly. There is a fairness to the processes. So that is the idea of a time sharing system or the time sharing. So there are some jobs like J1, J2, and J3 according to previous example only. They have arrived at a 0. It needed 200 units. It needed 10 units. It needed only 4 units. So this is your job ID, process ID. This is your arrival time. This is what you need CPU burst time. Then, as usually, first J1 is given a chance to CPU. And J1 is executed how many units? 10 units. Then J1 will be removed from CPU and J2 will be added. It also executed for 10 units of time. It's completely executed. Then after that, what is there? J3. Because you are executing based on time sharing. How much time you are giving? Let us say that I am giving on 10. If it is 2, you need to execute. If at all the time is shared among the process 10, then it is executed 10, balance is 190. It is executed 10, balance G0. You can remove this because it's completed. And I don't need 10, I need only 4. It executed for 4. Then it also remove. Then chance will be given to whom? J1. So J1 is executed for next 10. Likewise, the processes are executed based on a round robin system. So therefore, it is an illusion to all the processor. It's an illusion to all the processor that we are able to run. That means all the processors are able to run parallelly. But realistically, it is not because you are executing the processes on time sharing manner. What is an idea? Sometimes CPU has a J1, sometimes CPU has a J2, sometimes CPU has a J3. Again, J1 will get a chance. Again, J2 will get a chance if at all they need. Again, J3 will get a chance. Again, J1 will get a chance. This is a round robin concept. So this is how it happens. First J1 is executed by CPU, or according to this figure, J4 is given a chance. Once J4 executed up to time quanta, here your time quantum is 2. Your time quantum is 2. Time quantum is also called as time slice. It is 2. So every process will be given a uniform execution by the CPU. And the other one is multiprocessor operating system. What is a multiprocessor operating system? So you are having a more than one CPU. You never see this kind of scenario. Your laptop and your desktop may be equipped with only one CPU only. But if you are having a multiple CPUs like this, or you are having octa-core, so your physical processor will split into 8 sub logical processors. In this case, they are all sharing about memory. They are all trying to share common memory. This is what is the concept of a multiprocessor. What is the advantage? I can run the different tasks at different CPU at a time. J1 is busy with CPU 1, J2 is busy with CPU 2, and J3 is busy with CPU. Nowadays, we are using multiprocessor concept only, octa-core. So this is how. There are two varieties, symmetric multiprocessor, so asymmetric multiprocessor operating system. It is completely based on shared OS and different jobs, how they are executed at different CPUs. Asymmetric. In asymmetric, not all the processors are ready for execution of the jobs. Let us say there is a CPU 1 and there is a CPU 2 and there is a CPU 3. This CPU 1 is acting as a master, and these CPUs are acting as a what? Child or slaves. And whenever a command has come from operating system regarding job, I want to execute job 1, and CPU 1 takes that instruction and see that to whom to give that job, CPU 2 or CPU 3. Then again one more job request has come. It first comes to master CPU, then it allocates to next process. So taking the job and assignment to some other processors is the concept of asymmetric. Master CPUs and slave CPUs. Distributed operating system, where you see that all the nowadays all the operating systems are completely based on cloud nature. Cloud. Everything we able to store in the cloud only. So such concepts are called as what? Distributed operating system. So processors communicate with one another through various communication lines, high-speed buses or telephone lines, and show sharing. User can access resources available at other sites which are in the network, like cloud. So nowadays we are getting a YouTube. You can able to download or upload the files. That's completely based on distributed OS. So this is how you could able to access the things with the help of what? Network. Real time OS. Real time means critical tasks to be completed within a finite amount of time. For example, suddenly flight navigation system is corrupted. Then immediately software engineers they have to rectify the problem what is there in the flight navigation system software. So they are all comes under into real time OS. And the other one is that pacemakers. The other one is that nuclear reactors. In foreign countries, you see that they are already well equipped with a nuclear reactor, well established generation of power from nuclear reactor. If it is shut down, then you can't generate the power. In such case, those missions have to be rectified on urgent basis. They are all completely based on hard real. Critical tasks supposed to be completed within a finite amount of time. Soft real. For example, today IRCT server is not working, then millions of tickets are stopped. In such case, you need to rectify IRCT's software. They all comes under into what? Soft real-time systems. So where are you going to use real-time operating system? Industrial control, like a robotics and flight control navigation systems and multimedia audio and video processing systems use a soft real-time constraints. Embedded operating system. What is embedded? A program is embedded into hardware chip. You may call it as a microcontrollers. Air condition as embedded operating system. Washing machine has a program embedded OS. Sensors has embedded OS. And you may talk about whatnot. ATM machines are completely embedded OS. They are designed embedded computer systems with the devices like washing machine, cards, thermostats, etc. They are typically very compact and efficient, designed to run with a limited hardware resources. You can't take it for granted for any kind of application to run. Handheld operating systems like mobile devices. So in the year of 2010, the Androids started their revolution. They are leading operating systems nowadays, completely written based, some of its code written using Java. So designed for devices with a limited battery life, smaller screens like a smartwatch you may talk about, and slower processors compared to PC. Interface heavily reliant on touchscreen interfaces and gesture recognition. Resource management, aggressive power management is a key feature, suspending apps quickly to save the battery. So these are different types of operating system. In that, the very important operating system is a time sharing and real-time operating systems and handheld devices.